Hi everybody, in this video lecture we are going to discuss about sets and Python. Sets and Python are nothing but what you have learnt as set theory in your mathematics. Okay, so these are data structures in Python which we can use equivalent to the set whatever we have learned in mathematics, right? So it will be useful when we have to solve some problems like this. So consider this problem. An university has published the results of the term and exam conducted in April. List of failures in physics, mathematics, chemistry and computer sciences available. Write a program to find the number of failures in the examination. Right? This includes the count of failures in one or more subjects. Right? What is given in the problem is you have the list of failures in physics, list of failures in mathematics, chemistry and then computer science. Now you have to find out the count of failures in one or more subjects, right? So you have to combine all these lists. That is, a person X who has failed in physics may not have failed in mathematics, or he might have failed in both the subjects and so on. So you have to include the details or register number of the students who have failed in at least one or more subjects, right? So when we were using set theory, what we will do is, if you have four sets now, it is like four sets you are having. A set of students register numbers of students who have failed in physics, set of register number of students who have failed in mathematics, set of students who have failed in chemistry, and set of students who have failed in computer science, right? And we will take union, and we know that in sets there is no duplication, right? So automatically duplication will be removed and a student register number will come only once, and the union operation will give you the set of students who have failed in register number of the set of students who have failed in one or more subjects. So if you take the count of that particular set, you will answer this question, right? So in Python also it provides you a set data structure which will work as set what we have learned in mathematics, right? So this is the PSC chart for the university result problem. What is the input is the register number of failures in maths, physics, chemistry and computer science. Individually you have to read separately failures in maths, failures in physics, failures in chemistry and computer science. And then processing, you are going to create list of register numbers who have failed in one or more subjects, and then count the number of failures, right? The output will be the count. So this is the pseudocode. Read maths failure, physics failure, chemistry failure and CS failure. Let failure be empty. For each item in the maths failure, add item to failure, right? So failure is going to represent the set of students who have failed in at least one subject. So what we are doing is, first of all, we are adding all the failures, maths failures into this failure, and then we are going to process the rest of the three sets. When we are processing, we are checking if it is not in the failure list. So for each item in physics failure, if item is not in failure, right, because there must not be duplication, isn't it? So if item is not in failure, then you are going to add the item to failure. Similarly, you do the same thing for chemistry failures, the same thing for CS failures, right? And then you are setting the count to 0, and then for each item in failure, you are just saying count equal to count plus 1 and then print count. This is the pseudocode for the particular problem, right? So now we are going to discuss about sets in Python. What are sets? Are unordered collection. So this is similar to dictionary. Okay, there is no index for the element. That is what is meant by unordered. When I print the set, any element can be first. Okay, it will change for each time because it is a collection of element, no order is preserved, right? So unordered collection of unique, right? As we have learnt in school, there will not be duplicates in sets. So only here we see an unordered collection of unique and immutable objects, right? So it cannot modify the objects that support operation corresponding to the mathematical set theory. Okay, so the objects inside the sets must be immutable, right? But sets by itself is mutable. What is meant by that is, I can change the first element, that is, I will change the element of a set, but I cannot change the element inside the set. So we will see in detail when we go through the lecture, right? And there are no duplicates. sets for I triple, you can take one by one. Okay, it can also grow or shrink on demand and may contain variety of objects. It's going to be heterogeneous. You can have one element to be integer, another element to be string or set, or list or anything, right? We will discuss, right? We can have tuples and it does not support indexing. Similar to dictionary, this particular data structure also do not support indexing because it is unordered. Okay, if a collection is unordered, then it will not support indexing. So consider this example. How do we represent a set is using curly braces only, right? So as we did in our school, here also we will use curly braces for representing a set. So x equal to 1, 2, 3, 4. So now you may have a doubt, for dictionary also we are representing using curly braces, but the difference is in dictionary, each element is a pair of entities. Okay, you will have a colon separating the key and the value. Okay, whereas here it is only one value for each item, right? Y equal to a set of strings and then x1 equal to set of spam. If I give like this, then Python will automatically prepare a set from a string. Okay, so each character will be taken and it will be prepared as a set of elements. Okay, so spam means it is taking SPAM and putting inside this particular set. Then I am saying add. When I want to add an element to the set, I can use this add function. So x1 dot add of allowed. Okay, already we have 4 elements in this x1. Now one more element allowed is also added. Since it is unordered, this allowed can be anywhere. When I was executing, I got it as the 4th member, but you may get it in different order, right? And then we see the set operations. The set operations, whatever we have learned in school, is also in Python. Okay, we know that union. Union is used to combine 2 sets, right? So now let us consider S1 equal to 1, 2, 3, 4. And then now we are going to make union with S2. What S2 contains is 1, 5, 3, 6, right? When you see the set S1 and S2, 1 and 3 are common elements. 1 and 3 are present in S1 as well as S2. Okay, so when you take union, these 4 elements will come. In addition, these 2 elements, there is the different elements 5 and 6 and 1 will come. So when you say print S2, it will print 1, 2, 3, 4, 5, 6. Okay, order may change. Once again, I insist that it's an unordered collection. Next is intersection. Intersection is used to find out common elements between the 2 sets. So for example, now I say S1 ampersand 1, 3, right? Now this is another one set and S1 is the set. Now common element between these two is 1, 3. So when I say print S2, it will print 1, 3 within curly braces, right? Difference. What is difference is when I want to find some, when I have 2 sets, okay, S1 and S2, I want to find the elements in S1 which are not in S2, then I will say S1 minus S2, right? So now in this example, we have a set S1. S1 contains 1, 2, 3, 4. Okay. Now I want to find the difference between that set and this set. This set contains 1, 3, 4. Right. So what the element that is in S1 which is not in S2. This is not S2. This particular set is 2. Right. So when I say the result is stored in S2. So when I say print S2, it will print 2 as a set. Okay. It will print within the curly braces. And then we have also seen some operations like superset, subset and set theory, isn't it? Python supports for that also. How you can check whether one set is superset of the other is this operator, greater than operator can be used for it, right? Now I am saying S2 equal to S1 greater than 1, 3. It checks whether all the elements here is present in S1. Okay, actually S1 is 1, 2, 3, 4. So both 1 and 3 elements of this particular set is in this set, right? So it will return true. So when I say print of S2, it will say true. And empty set can be created with set built in and also it can be printed in the same way, right? Already we have seen that empty dictionary is represented by empty curly brace. So it is not possible for us to represent the same way empty set, right? So how Python represent empty set is set curly braces, right? So we can check this and ideally, okay, so now I say S equal to empty curly braces. Actually Python will take this as empty dictionary, okay, right? Now I say type function can be used to check what is the data type of a particular variable. Now I say type of S, you can see that it is printing as dict. Dict is used to denote dictionaries in Python. Now I say, how will I represent empty set is, I will say like this, set empty parenthesis. Like now I will say type of S. It will say as class set. Okay, so clear? You can also check it, and then you can use this union operator, right? I can take union of one set and another set. Already we have seen it, but I cannot combine with a list. If I do like this, a set and a list, I will get a error. Okay, so suppose if I have a list of items and I want to find out what union of the elements in the list and some other set, what I can do is I can convert that list to a set. So how I will convert is just by set and the list of elements. This will be converted to list set, and you can take union, right? And there are two ways in Python. One is the OR operator, by which, or the pipeline symbol, which you can use for taking union, or else you can use this union function also, right? This is one set dot union of this. Okay, you can use like this. Sorry, this will raise to error. Actually, the next one will work out. We'll just check it. Oh, when you are using OR operator, you have to explicitly convert it into, can check it. When you use the OR operator, you have to explicitly convert this list to a set, then only it works. But whereas if you use this union, it automatically internally converts this list to a set and then takes the union, right? And then about immutable, constraint and frozen set, right? In the first slide itself, we saw that sets can contain only immutable objects, right? Immutable means that cannot be modified. We have already discussed that there are 4 types of sequences basically in Python, right? There is strings, list, set and dictionary. Okay, sorry, list, string, list, tuple and dictionary. These are the 4 types of sequences, right? And set is an advanced type. Okay, so when you see here, we have seen that string and tuple are immutable, they cannot be modified, whereas if you consider list and dictionary, they are mutable sequences. Okay, now we see the constraint for a set. The set can contain only immutable object types. So what does it mean is, within a set I can have a string or I can have a tuple as one of the element, whereas I cannot have a list or a dictionary because they are mutable, right? So see this example. Now I have a set S. S is with only one element. This is a singleton set with 1.23 as element. Now I am trying to add S dot add of 1, 2, 3 inside a list. Okay, now we are trying to add a list of elements 1, 2, 3. Now we will get a error called as type error, which is saying that unhashable type, because we saw that inside a set there can be only immutable objects. List is a mutable object, so it will not be added. You will get an error. Similarly, I cannot add a dictionary into a set, then also I will get a error. But whereas for tuple it will work. So when I say S dot add of 1, 2, 3 as a tuple, it will add, and you will see when you print S, you see that this is the first element 1.23 which was in the set already, and then this new element as a tuple itself will be added, right? I cannot check whether one is a member of yes, that is not possible. Okay, it will return only false, right? So we can check this in the prompt. This is the singleton set. Okay, then I say S dot add, you will see that you get like this, right? Now if I say 1 in guess, okay, you will get false because 1 is not a member of this particular set S. But whereas if I check like this 1, 2, 3 in guess, I will get true because it is stored as a tuple only. Okay, it is stored as a object itself. And then you can also take a union of, this is a set. Okay, in this example this is a set with 2 elements. When you see the number of elements here, it is only 2. The first element is a tuple with elements 4, 5, 6. Second element is also a tuple with 1, 2, 3. Okay, now you are taking union. So already S had 1.23. Now we will have 3 elements in this. Okay, 1.23 first tuple and the second tuple. Now you can check like this as I show, but I cannot combine the elements in the tuples. 1, 4, 3 and yes will return me false. Right? And what is the use of clear is? Clear is used to remove all the elements in the set. Okay, so for example, if you consider cities, there are 3 elements in the cities. Okay, it is a set. Now after this you are using the clear function. As soon as you clear, all the elements will be removed. So if you say cities, it will print a empty set. Okay, and then next is copy method in set. Okay, copy method is similar to copy method that we have seen in dictionaries, right? Where it does a shallow copy. Okay, it will create another one memory space and copy the values from the source to the destination, right? So for example, if you have more cities, okay, with 3 elements like this, cities backup is another one variable, right? I am saying more cities dot copy. So what will happen when this line of code is getting executed is, one more memory piece will be allocated and each element from more cities will be copied into the cities backup. Okay, this memory is different, this memory is different when you use copy, right? I can just show a demo of this so that you will become more clear, right? So now we are saying more cities equal to this one, right? And then you say cities backup equal to this one, right? And then more cities dot clear. Okay, more cities dot clear. Now when you print more cities, you should get a empty set, isn't it? Because you have removed the functionality of clear as, it will remove all the elements in the set, so you get a empty set. Whereas if you try to print the elements in cities backup, okay, then it's going to be as it is. Okay, because the memory allocated for more cities is different from this. Now we will do again. Now I say more cities equal to this one, right? And I say cities backup equal to, instead of saying more cities dot copy, I am going to say simply more cities. Okay, so what will happen when I say like this is, the same memory location will be having 2 names now. There is only one piece of memory allocated. Okay, that was initially allocated for more cities. The same memory location will be pointed by this city's backup. Can you understand? It is like a alias name that we have. Now what I do is, I clear the content of more cities. Okay, now when I try to print the content in cities backup, I will get empty only, because please understand, copy only will create a new piece of memory and copy the values from the original thing into this. Okay, so when I say cities backup equal to more cities dot copy, a separate memory allocation is made, and that is named as cities backup, and each element from more cities is copied into the cities backup. So even if I clear one of the things, there is no problem at all. I can say more cities dot clear or cities backup dot clear. The other one will be having the content. Okay, but whereas if I say cities backup equal to more cities, then the same memory piece is having 2 names, that's all. Okay, so even if I clear through one of the name, when I access through the other name, I will get the same result only. That is the difference between copy and merely saying equal to, right? And this is called a shallow copy, right? So what is explained here. And next method in set is difference update. Okay, what is the use of this difference updated? It will remove all the elements of one set and store it there. For example, if I say x dot difference update of y, then it means that it is equivalent to saying x equal to x minus y. Okay, so what is x minus y is? Content in x which is not in y. Okay, x will be modified to content which is in x and not in y. Okay, so consider this example. Now I have x with 5 elements a, b, c, d, e and y with 2 elements b and c. When I say x dot difference update, then it will have all elements in x which are not in y, right? So a and b are, a is not in y, so a will be in the result, b is there, it will not be there, c is there, in y it will not be there. So I will have the result as a, d, e. Okay, the order may change because it's a unordered collection, but I will have only these 3 elements. And the next function in set is discard. Okay, so when I say discard of a particular element, that element will be removed from the set if it is contained in the set and nothing will be done otherwise. So for example, if you are having 5 elements in X, when I say discard of A will be removed, so remaining 4 elements will be there. Okay, but I say X dot discard of Z is not at all in the set, nothing will happen. Okay, so when I print X, I will see all elements whichever is an X will be there. Okay, X is modified to now 4 elements BCDE, all the BCDE are now available when I say discard of a element which is not in the set. Okay, the equivalent function is remove, but there is a difference between remove and discard. Okay, remove will be behaving in the same way as discard when the element is in the set. Okay, so if I say X dot remove of A, element A is in the set, so it will be removed. The output will be equivalent to discard. But when I am trying to remove an element which is not in the set, now I say X dot remove of Z. Z is not in the set X. In that case, I will get an error. This is the difference between discard and remove. Okay, so when I said discard of Z, nothing happened. It didn't give me a error. But when I say remove of Z, the element which is not in the set, remove will give me error, whereas discard will not give me error. This is the difference, right? Is disjoint. This function, we know that disjoint sets means those two sets do not have any common elements. So this disjoint is going to check whether the elements between the two sets are null. Okay, there is no common element at all. You can use this is disjoint function to check. Is disjoint will return a Boolean value true or false. If the method returns true, then it means that they are disjoint sets. Okay, similarly you can use is subset. This is subset is equivalent to this operator, less than, greater than operator. Okay, the abbreviation is you can use in two ways. Simply you can say less than when you want to check proper subset. When you want to check subset of, okay, you know the difference between proper subset and subset. Okay, suppose if the set is S with elements 1, 2, 3, right? Proper subset means all subsets except itself and null set. That is what is called as proper subset. Okay, whereas equal to is there means if I have another one set Y which is also containing 1, 2, 3, then it will say equal to. Okay, that is the difference, right? So less than or equal to is abbreviation of subset of, and greater than or equal to is abbreviation of superset of, right? And less than alone, if you are using without the equal to symbol, then it is used to check if a set is proper subset of a set, right? So if is superset returns true if X is superset of Y, and greater than equal to can be used. Similarly, greater than is used to check proper superset of a set, right? So suppose if I am having X is equal to 5 elements A, B, C, D, E, and Y is equal to 2 elements C and D, X dot is superset of Y. Okay, it is checking whether X is a superset of Y. Yes, it is superset because all the elements in Y are also elements of X. In addition, it has some more elements. So it is saying true. Okay, I am just checking X greater than Y. It is equal to checking superset. So it is saying true. X greater than equal to or equal to. Okay, greater than or equal to Y, then also it is true, right? X is greater than equal to X, then also it is true because it is equal. When I say greater than equal to X, all the elements, okay, it is checking for itself, so it is true. But whereas if we check X greater than X, it is false. Okay, because it must be greater than symbol checks whether they are proper subset or proper superset. In this case, I will get false because all the elements are same. So we are checking the set with itself, right? X dot is superset of X. Yes, true, right? This is like greater than or equal to. Okay, and similarly is subset also you can just work out and see. Okay, and then pop removes and returns an arbitrary set element. Pop is used for removing the elements, but it will remove any element. It will not be in any order. Okay, since it's unordered collection, any one of the element will be removed from the set. Okay, and the method raises a key error if the set is empty. Here, for example, I have 5 elements in the set X. When I say X dot pop, I will get A. Next time when I say X dot pop, I may get C. This may differ for execution to execution. There is no guarantee that you will get only the first or the last or anything. Okay. Set themselves are mutable too. They can be changed. So only we have a pop method, right? Sets themselves are mutable too. So cannot be nested in other sets. So what we saw about set is mutable. That is, I can change one of the element of the set, but I cannot put mutable objects inside the set. Okay, so we saw in the beginning that you cannot place a list or you cannot place a dictionary inside the set. So it is not possible for us to directly place a set inside another set. That is what is said here. Since set by themselves are mutable, you cannot nest in other sets directly. So if you want to store a set inside another set, the frozen set built-in call have to work. Okay, we have a concept called as frozen set. Okay, when we use this frozen set, the set becomes read-only. It cannot be modified, right? So we will use this frozen set to make it to put it inside another set. So you see here, city is frozen set of list of elements. So now our set will be prepared and that will be like a read-only set. You cannot modify. So when I try to add a new city into the cities set, it is giving me a error because frozen set do not have the add method. You cannot modify, you cannot add, or you cannot pop, or you cannot remove. You can do anything in this particular frozen set. Discard, none of the method will work when you make a set to be frozen set, right? And there are set comprehensions as we have for other cases. This is just an example. That is, I have a list of elements, right? I am going to prepare a set in which I am just squaring the elements in the list and putting it, right? So I am saying x square means 1 square, 2 square, 3 square, 4 square. So I will get like this. And similarly x for x in span, right? You will get like this. C star 4 for C in span. So each letter will be taken and repeated 4 times, right? These are examples. And you can take this is union. Okay, we already said that R is for union, ampersand is for intersection. So those operations also can be formed with the resultant set what we get through comprehensions, right? Now this is the code for the problem what we discussed in the beginning of the lecture. So first what we are doing is we are creating 4 sets, empty sets. This math represents the failures in mathematics, PHY represents the failures in physics, CHE represents the failures in chemistry, and then CS represents the set of failures in computer science. Initially they are empty, and then we are getting the number of failures in mathematics, right? And then we are getting the register number of the failure. If there are m_n failures, we are running a loop and getting the register number of the failures. And then I am making a OR. So since I am interested in, I can use add method also. That is one way. Here I am just using OR. When I am saying OR, it means that union. Union expects 2 sets. Math is a set, but this val is a single value. So what I am doing is I am making it as a single set by putting it within a set of a pair of curly braces, right? Now I can do like this, or you can also use the add method. No harm in it. Now m_p represents the number of failures in physics, right? So I am getting the number of failures from the user and then getting the register numbers from the user. Similarly, I am using union operation to add the list of failures into the physics set. Similarly, chemistry, right? I am getting from the user the number of failures in chemistry and then register numbers added there. And then computer science, number of failures in computer science, their register numbers added. Now I want to find out the failure list. Just I am taking union of all the 4 sets. Just put a OR symbol, it's sufficient. And then len method, as we have for other structures. Here also you can use the len method to know how many students have failed. Okay, failure set represents the register number of all failures in the subjects, all the 4 subjects. Okay, it's union, and len will return the number of elements in the failure set. Okay, this is about set, and you can work out the practice problems and then you can see.